In this video, I shall show you how to convert binary, octal and hexadecimal numbers into decimal numbers. So let us jump into the coding part. So first I shall create a new file and I shall first save it in the name number conversions, CONV, conversion. So I just browse it to the point where I want to save my file. So this is the location, and now what I do is I start writing the program. So suppose I have taken any arbitrarily chosen variable in the name bin underscore number. This is for binary number, and suppose the number is equals to, so as I have already told you that binary number is prefixed with 0 b. It can be small b or it can be capital B, that is absolutely fine. So 10110001, suppose this is the number, this is the binary number. Now if I want to print this binary number, then what I have to write, print, and I shall print now this, the decimal equivalent. Suppose decimal equivalent of the binary number is equals to, suppose I write here bin underscore number, so which is my binary number. Okay, so I just save it. I save it, Control S, then F5, and you can see here decimal equivalent of the binary number is equals to 177. So that means this binary number, when you convert it into decimal number, then we get 177. So similarly if I write something like, suppose I take one octal variable. Now this is the binary variable. Now suppose I take one octal variable. So to do that, what I shall do is I shall write OCT for octal. So octal numbers are prefixed with 0, then small o or capital O. So I choose it to be small o. Then the permissible digits are from 0 to 7. So I write something like 56107, suppose this is my number. Then decimal equivalent of the octal number, so I write here octal number is equals to, so here I want to print the decimal equivalent of the octal number. So I save it, I run it. Now you can see the decimal equivalent of this octal number is this one. So I can do the same thing for hexadecimal number also. So suppose I write here HEX, hex for hexadecimal number. So hexadecimal number is prefixed with 0, small x or capital X. So I choose it to be small x, and the permissible digits are from 0 to 9, then A to F. So I choose it to be, suppose this is A to 3, FF. Suppose I have arbitrarily chosen this one. So decimal equivalent of the hexadecimal number is equals to, suppose HEX. I write here HEX. Now I save it, I run it, and you see I get so beautiful outputs, So this is the decimal equivalent of this hexadecimal number. Okay, now there is one more method, that suppose I do not use this prefix called 0b. So I remove this one. So first what I shall do is I shall consider it as a comment, multi-line comment. Okay, so now what I want to do is I shall now convert. Now my Python interpreter does not know what is this. So at this point of time, if I just save it and I run it, you can see the decimal equivalent of the binary number is exactly same number as this one. So that means Python has considered this number as a decimal number rather than a binary number. So what we can do? So what we can do is we can take one decimal underscore number, means equivalent decimal number, or suppose EQ for equivalent decimal number, and I equate it, I actually convert this number, this binary number, okay, bin underscore no, and I also instruct that, sorry, this one will be equal, okay, and I also instruct that the base of this number is 2 for binary number system, okay. So now I print here equivalent decimal number, so EQ underscore decimal underscore number. So I save it, I run it. Now you can see here basically there is an error. So trace back, if you really look at it and read it, then what you get? Trace back most recent call last, then your file name, then line number 3 it is showing in the module, equivalent underscore decimal underscore number is equals to this one, type error. The error is integer parenthesis cannot convert non-string with explicit base. So I have explicitly mentioned here the base, which is 2, but the problem is this is non-string. So if I take it, if I make it a string, then it will be fine, the error will be removed, gone. So I save it, I run it. Now you can see here 177, you can see 177. So similarly I can do the similar things for this one, octal number also. So how I do that? This one I write it, suppose this one, this exact same line I have to use in this one, and here in this case I have to write that octal number whose base is now 8, and convert it into integer and then store it into equivalent decimal number, and then just print it. So I just print it here, okay. So I save it, I run it, okay. Again, so sorry, I just forgot to remove this, so I have to remove the prefix as well as I have to consider it as a string. So I save it, I run it. Now you can see 23623. So earlier also you can see 23623, okay. So now for hexadecimal also we shall do the same thing, okay. So this one is fine. So this one I just copy it and I paste it. Then I have to write here hexadecimal number HEX whose base is 16, and I shall have to remove this prefix, and I have to consider it as a string, okay. So this is decimal equivalent of the hexadecimal number. So I shall write it here, hexadecimal number is equivalent decimal number. Now at this point of time I just want to tell you something explicitly, that earlier we have used the prefix. For binary it was 0b, for octal it was 0o, for hexadecimal it was 0x. Now in this case when we consider these as string, in that case we do not use the prefix, okay. Instead we consider them as a string, and we instruct the Python interpreter to convert that particular number, and we provide the base of that number system, okay. So let me save it, then run it by pressing F5, and you can see, oh my god, 664575. I just want to check it, 664575. So that is absolutely fine and beautiful. So I hope you have understood. Okay, so we shall meet again in the next video. Thank you.